Continuing with the unit on functions, we are now looking at function notation. So functions we should know are one-to-one. They pass the vertical line test. That's what we did with drawings. But now we're going to actually looking at some algebra stuff. And functions will typically look something like this. Some sort of equation. And we've graphed this before. This is actually a line. So anyways, sometimes we can put things in. So let's say x is 2. So I can put in here y equals 2 times 2 plus 3, because we put in an x is 2 here. And then 2 times 2 is 4 plus 3. And then y is equal to 7. Now what's interesting about this is it tells me that y is equal to 7. So we put in a number, but it doesn't say what number we put in. Remember, we put in the number 2 when x is 2, but this only tells you what is outputted. 7 is outputted. So what we want to do is we want to come up with a better way to write this. We want to write it something that says like y when x is 2 equals 7. That way we know, just looking at the final answer, oh, we put in 2 and then ended up getting y is equal to 7. And so that's what we're going to do here. We're going to do something with function notation. So normally we would write things like this, y equals 2x minus 3. But we're not going to write it like that anymore. We're instead going to write like this, g of x equals 2x minus 3. So this is not g times x. This is just g, and then we say, when x is 7. So we're going to write down right here, this just means when x is a particular number. This is just telling the reader that x is going to be some number. And we'll do some examples here, okay? So let's take a look. Okay, so it tells me the old way that we would have read this is y equals, and then we would sort of had 3x squared minus 6x plus 4. So this would have been the old way. And now we're going to do this the new way. And so what we want to do is put in, let's take a look at the first one, 2. We want to put 2 into the question. This says there's a function g, and we're going to put 2 in. So g of 2, this is not g times 2, it's g of 2, is equal to, and then we can actually just put 2 into here. So 3, and then x squared will be 2 squared minus 6 times 2 plus 4. And then we can just do some math. G of 2, 2 squared is 4. So this is actually 3 times 4. 6 times 2 is 12, plus a 4. And then g of 2 is equal to 3 times 4 is 12, minus 12 plus 4. And now we can add all of those up together. So g of 2, so 12 minus 12 is 0. 0 plus 4 is 4. So now this tells us, okay, well, we had an output of 4, and what was the number that we put in? We put in 2. So that's why we like this. Normally, we would just say y equals 4, and we would have thought, well, what number did we put in again? So this method, this function notation method, is really good for telling us, well, this was the input. We input a number 2, and then we did an output of 4. Okay, let's try another one here. So we're using the same function, so we're going to use this same function, but now we're going to put in -1. So we're going to input a -1. So 3 times -1 squared minus 6 times -1, and then plus a 4. So -1 squared is just going to become a +1. And -6 times -1 is going to be a +6 plus 4. 3 times 1 is just a 3 plus 6 plus 4. And then that ends up being what, 13? 13. So g of -1 is equal to 13. You don't always need to write g of -1. You can if you want, but it's not necessary. You can just write it at the beginning and then write it here at the end. Okay, let's do some more practice here. G of a third. Okay, so g of a third is equal to, I don't know what the equation is anymore, 3x squared minus 6x. So 3x, in this case it's a third, 3x squared minus 6 times x, which in this case it's a third, plus 4. Yeah. Okay. So we got to bring this 2 in, so we're going to square the 1 and we're going to square the 3. So there's a 3 on the outside, and then squaring 1 would be 1. 1 times 1 is 1. And then on the bottom, 3 times 3, 3 squared is 9. Minus, and just keep in mind that this is over 1. And you can, whenever you multiply fractions, you do the tops together and the bottoms. So negative 6 times 1 would be the negative, oh, there's a negative there. So 6 times 1 is 6. 1 times 3 is 3. Plus 4. And again, this is a fraction. So you can multiply the numerators. 3 times 1 is 3. 1 times 9 is 9. Minus. The 6 over 3 is just a 2. Plus a 4. Okay. And 3 over 9, well, that is just a 1 over 3. And I've got a negative 2 and a positive 4, which ends up being a plus 2. So I end up getting a third plus 2. Now, whenever you add fractions, you're going to need a common denominator. So this is over 1. I'll times this by 3, and I'll times this by 3. And I guess I'll bring this over here. So g of a third equals, I had to write the g of a third because I'm moving everything over to the right a little bit. So you have a 1 over 3 plus a 6 over 3, which would be g of a third is 7 over 3. Okay, so that all of a sudden got way more complicated just because there was a fraction in there and that fraction was squared. So you had to square the 1 and square the 3 to get a 1 over 9. And then you had to multiply that fraction together, 3 times 1 and 1 times 9, even though the 1 wasn't there. And of course you had to multiply those fractions together, 6 times 1 and 1 times 3. And then at the very end you then had to add 2 fractions together, which required a common denominator. Okay. Now we can do things here where we can do g of 1 minus g of 5. Actually, let's do that one in the next video. I'll just zoom out here in case anyone needs to copy any of this stuff down. And then I'll just make the next 3 questions can be in another video.